Abdullah, you have any idea of Noor? Abdullah, Fazil?
No, sir. Sir, I'll call him.
रुक जाओ अब्दुल्ला, रुक जाओ, जस्ट वेट कर लेते हैं क्योंकि सानिया का भी इशू है, उसका नंबर नहीं है किसी के पास. You had your any physics test recently in school?
No, sir.
Fazil, Abdullah?
No, sir.
No. Basically, I want to start chapter number 3 today. That error we will finish in the next weekends. I was planning to complete chapter 3 in extra classes. I don't want to start without 2 students. Just wait for 2 more minutes and then we will decide. Fazil, Abdullah, you have any doubts from the assignment, that dimensional analysis? Any doubts from that assignment? Abdullah, you have started chapter 3, but Fazil haven't. Abdullah, for you, it's only error analysis is missing, na? So up to chapter number 6, Abdullah, you have completed everything else than error analysis. So you can skip these classes because I will start error on Saturday and Sunday only. In these extra classes, just want to concentrate on chapter number 3 and chapter number 4. Because Fazil and other students haven't done it. Yes, Abdullah, वहाँ complete हो जाएगा. Okay, so let's start with. See, in chapter number 2, we are left with just 2 topics. One is error analysis. And the next is measurement of length, mass, and time. Measurement of length, mass, and time. This we will do on weekends only, Saturday and Sunday. This we will complete on weekends only, on Saturday and Sunday. Okay, I have completed vectors with you people. We had 2 weeks of classes, Fazil and Noor.
Yes,
You
sir.
both, we have completed vectors up to dot and cross product, or what was the last topic in vectors? Remember?
Sir, polygon, I guess.
Which one? Polygon law.
Polygon law of vector.
Tradition was last topic. So that's enough. So we'll do this in Saturday and Sunday. I'm starting chapter number 3. After chapter number 2, the next is chapter number 3. Let's start with chapter number 3. Chapter number 3 is motion in a straight line. Motion in straight line. But to understand this motion in a straight line, first we have to complete a small course on mathematical physics. We have to do a small course on mathematical physics. Small course on mathematical physics. In mathematical physics, you need just one topic, that is calculus. Without calculus, you can't solve numericals of motion in straight line, chapter number 3 of NCERT. So first we will start with calculus. See, calculus, just like algebra, it's a branch of physics. Sorry, a branch of maths. Up to class 10th, you have done some branches, like you must have done algebra. You have done, yes, Abdullah, if you want, you can leave. No issues. It was algebra, it was trigonometry. You must have done statistics, geometry. Just like algebra, there is one more branch, which is this calculus. Algebra is based on 4 operations like addition, subtraction, multiplication, and division. Algebra is based on following 4 operations: addition, subtraction, multiplication, and division. Rather, calculus is based on 2 operations only. One is differentiation. It's based on 2 operations. One is differentiation. Another is integration. It is based on these 2 operations. One is differentiation, another is integration. Before starting differentiation, let's start. Fazil and Noor, you both have maths?
No, sir, I'm not taking maths.
You have not taken maths, okay.
I'm taking.
You have taken. This differentiation and integration starts with the definition of function. Let's see what is function first. So just like algebra, you have another branch of mathematics, which is calculus. Algebra is based on 4 operations. Calculus is based on just 2 operations. One is differentiation, another is integration. Let's start with functions. Functions is a special type of relation between dependent and independent variables. Between dependent and independent variable. Independent variable. So the relation between dependent and independent variables is known as function. We just have to know, you should know just the definition of function, that is what is function, nothing else. We won't be using calculation or numericals based on function, because you just know what is function. A function means a very special type of relation between dependent and independent variable. Now this special means some conditions of range and domain, which I'm not discussing here. Function is simply a very special type of relation between dependent and independent variable. That relation is known as function. For example, So you have this equation y is equal to 3x. Here y is a variable, x is a variable, but 3 is a constant. We call x as independent variable. X is independent variable. Y is dependent variable. Y is dependent variable. And this 3 is a constant. So it's a relation between dependent variable, independent variable, and constant. So you can say that y is related to x. You can say that y is a function of x. Independent variable means a variable which can take any value. You can put any value of independent variable as per your choice, but the value of dependent variable will depend upon the value of x. Like if I take x equal to 1, if I take x equal to 1, then your y will be 3 into 1, that's 1, 3. Is it possible that, say, if I choose x equal to 1 and I write y equal to 2, is it possible? No.
No, sir.
So the value of y depends upon the value of x. So we call y as dependent variable and x as a simple independent variable. And this 3 is just a constant. Similarly, so you can write this as that y depends on x, so y is a function of x. Y is a function of x. Similarly, you can even write this as y equal to sine x. Y again depends upon x, but through a trigonometric function. So again, y is a function of x. So you can have many types of functions. In general, you can represent a function in this way. Y is f of x. Y is a function of x. Here this x is independent variable. Here x is independent variable. And y is dependent variable. X is independent variable and y is dependent variable. So that is the relation between y and x in general. Y is fx, x is independent variable, and here y is dependent variable. This is general representation of function. In NCRT, he will use this languages like he will say that velocity vt. This means this particular notation means velocity is a function of time. This means velocity is function of time. So Noor, which one is independent variable here? Velocity or time?
So time is independent.
Time is independent. One which is inside the bracket is independent. So V is, if in NCRT somewhere you get V as bracket of t, that means V is a function of t. It simply means velocity depends upon time. Velocity is not constant, it's variable. Next we have types of functions. We have few types of functions. Like the one is algebraic function. It could be trigonometric. It could be logarithmic. Or your function could be exponential. So you have following 4 types of functions: algebraic, trigonometric, logarithmic, exponential. You can have more type of functions. So for chapter 3 or for mechanics, you just need to know this much about function, that what is function, the general notation of function, and some types of functions only. So is it clear?
Yes, sir, it's there.
Yes, sir.
Note it down or erase it.
I'm done, sir.
Okay, the next is differentiation. So to start with differentiation, you should know some notation. Like the first notation is of delta. Delta in maths means finite small change. Delta means finite small change. Finite small change is represented by delta. If I write delta t simply means finite small change in t. Or you can write this as, for example, like delta t is 0.0001. Delta means your change is small, but it's still finite. So finite small change is represented by delta. There's one important thing, like whenever you have delta in your equations, you are in algebraic regime. Whenever you have delta in your equation, that means you are still in algebraic regime. Means you can use algebra. You can use addition, subtraction, multiplication, and division if you have delta. There's one more type of change which is represented by small d. Small d here represents infinitesimal small change. Infinitesimal small change. Infinitesimal small change is represented by small d. So if I write dt, dt simply means infinitesimal small change. Infinitesimal small change means this change is extremely small. Like you can say that your dt is 0. Extremely small change. This is in the neighborhood of 0. If I put numbers, then this is almost like this one. It can be even smaller. If on the number line this is 0, then dt is somewhat here. It's in the neighborhood of 0. And whenever you have d in your equation, that means you are in calculus. You have to use calculus. You have to use differentiation or integration. So these are two types of changes. Delta means finite change and d means infinitesimal small change. Let's take another example. So if I write y is equal to fx, y is a function of x. So here y is dependent variable and x is independent variable. Okay, can you guess if I change x by an amount dx? What do you mean by dx? It's a finite change or an infinitesimal small change? Dx means
Infinitesimal small change.
if I change x by a very small amount, then can you guess how will this y change? How this y will change? It can change by a large amount or it will change by small amount only.
Oh,
Small amount. If you are changing x by a very small amount, since y depends upon x, so y will again change by a very small amount. That's dy. So if you're changing x by an infinitesimal small amount, then your y will again change by infinitesimal small amount. Now you are supposed to calculate dy over dx. Dy over dx physically means infinitesimal small change in y with respect to x. Means when you are changing x by an infinitesimal small amount, then your y will again change by an infinitesimal small amount, and change in y with respect to x is written as dy over dx. This dy is a single term. You cannot cancel this d with d. This dy and dx are just single terms. And mathematically, we call this is differentiation. This is differentiation. of y with respect to x. So this is how we differentiate y with respect to x now. We write this as simply dy over dx. This is differentiation of y with respect to x. That's dy over. So this is differentiation. Differentiation means change in one variable, infinitesimal small change in one variable with respect to another. And this is how we write it mathematically. This is differentiation of y with respect to x only. This is symbol of differentiation. Like this is symbol of addition. This is symbol of subtraction, multiplication, division. This d over dx is symbol of differentiation. That means you are differentiating y with respect to x now. Similarly, if I ask you to differentiate, say, if I ask you to differentiate velocity or differentiate position with respect to time. If I ask you to differentiate position with respect to time, then you can simply write this as position you usually represent by x. This is simply dx over dt. Can you guess the unit of this quantity? Noor? The unit of dx over dt?
Meter per second.
Meter per second. So meter per second means this is velocity.
Yes.
This is the expression of velocity basically. This is the expression for a velocity which is known as instantaneous velocity. We will do this instantaneous velocity in detail when we start chapter 3 from the starting, but right now this is one application of differentiation, that velocity is dx over dt. This is application of differentiation. You can have another application. Applications of differentiation. This application of differentiation is velocity. You will use one more application of differentiation in chapter number 3, and that is differentiation of velocity with respect to time. Can you guess change in velocity with respect to time? What is this quantity? dv over dt.
Acceleration. Instantaneous acceleration.
This quantity is acceleration. When you differentiate velocity with respect to time, the quantity is known as acceleration. So you have following two quantities: instantaneous velocity, which is dx over dt, acceleration, which is dv over dt. So these are two simple applications of differentiation. Note it down. Then we'll do formula for numericals. So shall I raise it?
Yes, sir.
Sure. Puzzle.
Yes, sir.
Now the differentiation depends upon the type of function. Let's consider the formula of differentiation for a polynomial function. Here, polynomial function simply means function of this form, y is x to the power n. So if I ask you to differentiate y with respect to x, which is dy over dx, then this would be d over dx of x to the power. And derivative of x to the power n is simply nx to the power n minus 1. This is differentiation of x to the power n with respect to x, which is nx to the power n minus 1. This This is how we differentiate x to the power n with respect to x. I'm not deriving this formula right now. You will do this derivation in mathematics if you have maths. If you opted for maths, then you will do this derivation. But in physics, we don't require this derivation. Just have to memorize this formula that x to the derivative of x to the power n is nx to the power n minus 1. Let's do some simple numericals on this expression. Say you have y is x cubed. So instead of n, I'm using 3 here. So you can simply write this as dy over dx is, it's d over dx of x cubed. And this is 3x to the power 3 minus 1, which is 3x squared. So this is the derivative of y with respect to x, which is 3x squared. Fazil and Noor, is it clear, this derivative?
Yes, sir.
Yes, sir.
If I change the variable, then this differentiation will not change. For example, if I, instead of y and x, I'm using x in t, if I take x equal to t cube. So say x is equal to 2t cube, I asked you to calculate velocity. So velocity is simply the derivative of position with respect to time. It's dx over dt only. So this is d over dt of t cube. You can compare here. Instead of x, I'm using t. Instead of n, I'm using 3. So that's 3 t to the power 3 minus 1. So this is the expression of velocity. Velocity is 3t squared. Clear?
Yes.
Yes.
Let's take one more example. Say you have an expression of position in this way, like x is 1 by t squared. I ask you to calculate velocity. See, whenever you have in this form 1 by t square, 1 by t cube, this is not the standard form. The standard form is this, x to the power n or t to the power n. So first bring this in standard form. For standard form, take this t square in numerator and this is t to the power minus 2. So now calculate velocity. Again. Noor, what should be velocity in this case? V is dx over dt. D over dt of t to the power minus 2. Yes, Noor. Complete this derivative. Yes, Noor. Complete this derivative.
So it's
Hmm.
e raised to minus 2 minus 1.
Yeah, minus 2 into t to the power minus 2 minus 1, right? Instead of n, I'm using minus 2. So that will be minus 2 t to the power minus 3.
It's 3.
So this is the expression of velocity, which is minus 2 t to the power minus 3.
Sir,
Yes.
the product rule also will be like same, right? The one which we studied in maths.
Yeah, the product rule will be same.
Okay.
You have differentiation in maths?
Yeah, we studied actually, like before vacation.
Okay, good. So v is minus 2 t to the power minus 3. Say you have x's, let's say x is t to the power 2 by 3. And you're supposed to calculate again velocity. Fazil, what should be the velocity in this case? Fazil, expression.
2 by 3 t to the power
Right.
minus 1 by 3.
It's 2 by 3 to the power. It's 2 by 3 minus 1. So your velocity will be, it's 2 by 3 t to the power minus 1 by 3. So these are some basic examples of differentiation. But Fazil, we won't do product tool and quotient tool here. We will not need these two rules. We just need basic addition and subtraction of functions.
Okay.
We'll do only those topics of calculus which we need to solve numericals of NCERT. That's it. Is it clear, Noor?
Yes, sir. So,
Just note it down.
Done, sir.
So next, trigonometric functions. The next is the trigonometric function. For trigonometric function, you just need to know the derivative of sin x and cos x only. So if you are differentiating sin x with respect to x, then the derivative of sin x would be cos x. If you are differentiating cos x with respect to x, then it would be minus of sin x. This is derivative of trigonometric functions. There are many more formula like for tan x, cot x, sec x, cos x, but that you will not use in numericals. So I'm just taking only those topics which you will need to solve numericals. Trigonometric function, in trigonometric function, you will use only sin x and cos x. Nothing else. After trigonometric function, there is exponential function. Exponential function. Function of the form e to the power x. If you are differentiating e to the power x with respect to x, then the derivative would be e to the power x. If you are differentiating e to the power x with respect to x, then the derivative would be e to the power x. So this is differentiation of e to the power x with respect to x, which is e to the power x. That's for exponential function. After exponential function, the next is logarithmic function. So exponential doesn't change during differentiation. The next is logarithmic function. So if I ask you to differentiate log x, then the derivative of log x is 1 by x1. So for differentiation, these four types of functions you will need: polynomial function, trigonometric function, exponential, and this final logarithmic function. Just note it down. Then we'll see some properties of differentiation. Shall I raise it? Fazil, Noor?
Yes, sir.
Okay.
Yes.
Next, we have some properties of differentiation. Properties of differentiation. The next are few properties of differentiation. So the first property is addition and subtraction of functions, or not addition and subtraction, first constant function. if you have a constant function, means say y is equal to k, where k is a constant. Differentiation means to calculate change, and constant means something which cannot change. So if you try to differentiate a constant with respect to any variable, like you are trying to differentiate this k with respect to any variable, you will get 0. Differentiation of a constant function is always 0. Instead of constant function, you can even use product of constant and variable function. For example, say you have y is k times some fx, where fx some variable function, k is a constant. When you differentiate this y with respect to x, that means it's d over dx of k times fx. You can take this k outside this integral, is a constant, and differentiate fx. See for here, if you are differentiating, let's say your y is equal to 3. Y is equal to 3. If you are differentiating 3 with respect to x, you will get 0. If you are differentiating 3 with respect to x, a constant 3 with respect to a variable x, then the derivative would be 0. Third one. One example on this second property, product of constant and a variable function. So you have something like it's 3x squared. If I differentiate this 3x squared with respect to x, Noor, what should be the derivative? 3x squared with respect to x? Final answer.
So 6x.
Very good. So 3 is constant. You can take this constant outside this integral and you are left with only x squared. So this is simply 3. The derivative of x squared is 2x to the power 2 minus 1. So this one is just 6x. So this is how we can differentiate y with respect to x. This is 6x only. Third property. If you have addition and subtraction of functions, addition and subtraction of functions. Say you have y, which is fx plus gx plus hx. So you have y, which is sum of 3 functions, fx, gx, and hx. So you're supposed to differentiate y with respect to x, dy over dx. So that is d over dx of fx plus d over dx of gx plus d over dx of hx. So this is how we differentiate y with respect to x, d over dx of fx, gx, and hx. If these functions have this negative sign, if you are subtracting fx and gx, then instead of positive sign, you will have negative sign. For example, say you have x equal to t cube plus t square minus 3. You are differentiating x with respect to t, that's dx over dt. That would be only just d over dt of t cube. Differentiate every function separately, d over dt of t square and d over dt of 3. So Fazil, what's derivative of t cube?
3t square
3t square. What's t square?
plus 2t,
2t, and about 3.
0.
So here dx over dt is 3t square plus 2t. And I can call this as velocity. velocity, which is dx over dt, is 3t square plus 2t. Noor, is it clear?
Yes, sir.
Okay, now solve this example. This is 3t to the power 5 by 2 minus 2 by t plus 3t. Calculate velocity. Just note it down and then solve this numerical.
Done.
So you put your answer in chat room, Fazil.
Okay.
So Noor, your answer? Okay. 2t to power minus. Okay, Fazil, correct. Noor, your answer? Q by Q. Noor, in the second step, there should be a positive sign. Instead of negative sign, there would be a positive sign.
So in the second term,
In the second point, there would be a positive sign.
okay, sir.
So your x is, you need dx over dt. Dx over dt is, it's d over dt of 3t to the power 5 by 2. You can write this 2 by t as 2t to the power minus 1 minus d over dt of 2t to the power minus 1 plus its d over dt of 3t. So your velocity v, which is equal to dx over dt, you can take this 3 outside this derivative, that's 3. It's d over dt of t to the power 5 by 2 minus 2, take this 2 outside this derivative, it's d over dt of t to the power minus 1. Then this is 3, take this 3 outside this derivative, this is d over dt of t. So you can write this as v is 3 If you are differentiating this t to the power 5 by 2, the result would be it's 5 by 2 t to the power 5 by 2 minus 1 minus 2, it's t to the power minus 1. If you can differentiate this t to the power minus 1, derivative is minus 1. T to the power minus 1 plus 3, this is t to the power 1. The derivative of this t to the power 1 is 1 into t to the power 1 minus 1. So this is 15 by 2 t to the power, it's 3 by 2 plus 2, it's t to the power minus 2 plus it's 3. So this is the final answer. This is your velocity if your position in this function. So that's all about differentiation. There are few more properties of differentiation like chain rule or product function or quotient rule, but you don't require them. You will not use them in numericals or anything. So that's about differentiation. Now let's solve integration. Shall I raise it?
Yes, sir.
Let's do one more question, one last question. Say the equation of position is, it's 3 by t cube minus 2 by t square minus 1 by t plus 5. This is the position, equation of position. Calculate first velocity, second acceleration. Velocity at t equal to 1 second. First differentiate this position with respect to time. You will get equation of velocity. In that equation, put t equal to 1. Then you would need acceleration at t equal to 1. Solve it. Answers. No, okay. Velocity is 9. Good. Put t equal to 1 in this expression, Noor. Okay, Fazil. This is velocity. Now, Noor, in the expression of velocity, put t equal to 1. And the expression of acceleration again, put t equal to 1 and calculate their numerical value.
Okay, sir.
So for velocity is dx over dt. We can write this as t to the power minus 3. This is t to the power minus 2. This is t to the power minus 2. So I'm differentiating it directly. 3 is a constant. You can take this constant outside the differentiation. T to the power minus 3 is minus 3 t to the power minus 3 minus 1. Minus 2, it's minus 2 t to the power minus 2 minus 1. Minus, it's minus 1 t to the power minus 1 minus 1. And the derivative of 5 is 0. So your velocity is minus 9 t to the power minus 4. It's plus 4 t to the power minus 3 plus t to the power minus 2. This is expression of velocity. Put t equal to 1. So this is minus 9, 1 to the power minus 4. It's plus 4. It's 1 to the power minus 3 plus 1 to the power minus 2. So velocity is minus 9 plus 4 plus 1. So it's minus 4 meter per second. For acceleration, just substitute this expression of velocity. Differentiate this once more. Acceleration is rate of change of velocity. It's dv over dt. So your acceleration will be, it's d over dt of v, which is minus 9 t to the power minus 4 plus 4 t to the power minus 3 plus t to the power minus 2. So your acceleration is, it's minus 9. When you're differentiating t to the power minus 4, it's minus 4 t to the power minus 5. 4 is constant, t to the power minus 3 is minus 3 t to the power minus 4, plus it's minus 2 t to the power minus 3. So the acceleration is minus 36 t to the power minus 5, minus 12 t to the power minus 4, minus 2 t to the power minus 3. So yeah, both of Noor, you're missing this 2. This 2 t to the power minus 3. Next, you need acceleration at t equal to 1. Put t equal to 1 in this equation. That's minus 6, 1 to the power minus 5, minus 12, 1 to the power minus 4, minus 2, 1 to the power minus 3. So this is acceleration, which is minus 36, minus 12, minus 2. The acceleration is minus 36, minus 12, minus 48, minus 2, minus 50. Minus 50 meter per second. Is it clear? Fazil, Noor,
Yes, sir, it's clear.
Noor,
Yes.
note it down.
Sir,
Yes.
the acceleration should be plus 36, right? 36 t to the power minus 5.
No, this is minus 36 t to the power minus 5, right? Just a second.
Because minus,
Right. That's plus 36. Yes, you are. Plus 36 minus 14, so that's just 22, huh?
yeah.
22 meters. Shall I raise it?
Yes, sir.
Sure. So the next thing is, so till now you have equation of position, you were calculating velocity. You have equation of velocity and you were calculating acceleration. What if you have velocity and you are asked to calculate position? Reverse. If you have acceleration and you are supposed to calculate velocity. It's a reverse calculation, right? Till now, we have position and we were calculating velocity. We have velocity and we were calculating acceleration. But the reverse one, if you have velocity, how would you calculate x? If you have acceleration, how would you calculate v? For the reverse calculation, you need a reverse operation of differentiation. And that reverse or inverse operation is known as integration. This inverse operation is known as integration. So you feel the need of integration for the reverse operation. You have velocity, you want to calculate position, acceleration, you want to calculate velocity. So to make this calculation the reverse direction, you need an operation which is inverse of differentiation. Just like multiplication is inverse of division, in the same way, the integration is inverse of differentiation. But time is over. So we'll continue with integration tomorrow. In weekdays, I can't take more than 1 hour. I have other meetings also. So for the weekdays, for the Monday to Friday, let's keep this class for 1 hour only. On Saturday and Sunday, we'll take it for 2 hours. So hopefully in the next 2 or 3 weeks, we will complete up to chapter number 5. One more thing. Tomorrow you have your school? No.
No, sir.
No. Can we keep it at 11 a.m. tomorrow? I have some meetings in the morning.
No problem, sir.
Bahrain time?
Sorry?
Bahrain time 11?
Yeah,
Or,
yeah.
okay.
Very time. Right?
Okay.
Okay, let's keep it at 11 tomorrow. So tomorrow we'll complete integration and we will start average velocity. Sure.
Thank you very much, sir.
Thank you, sir.